28 over 3 is equal to 15 over 28V. Okay, and this also corresponds to our F3. Okay, so now we have everything now. Okay, we have everything now. So the last step is to find the shear center. Okay, so now, so we have all our forces already. Let me copy the diagram again. Let me get this diagram across. Yeah, so now we know what is our F1. Our F1 is equal to, I can't remember what is it now. Our F1 is 5V over 56. And we know our F2 or F3. So this one corresponds to 15 over 28V. Okay. So from here, we are going to find the shear center. Okay, we're going to find the shear center. So we're going to take our summation moment in the x-axis at point C is equal to 0. So I have labeled this. This is our point C. Okay, so that is our point C. So from here, the F1 and F4 is going to generate a clockwise rotation. So minus twice. Okay, this is because of F1 and F4. So it will be 5V over 56. And then the perpendicular distance is 2A. Okay, that is our perpendicular distance. Then F2 and F3 relative to point C, they are both going to generate a anti-clockwise rotation. Right? They are going to generate anti-clockwise. So plus by twice. F2 and F3 are the same, 15 B over 28. And then the distance, 15V. And the distance, the perpendicular distance is A. Okay. And then V over here, right? That is our V is acting at point O. So we are going to plus is going to act in a anti-clockwise direction. So this is our VE is equal to 0. Okay. Can you go over how you turn dA to TDX? Okay. So dA is the change in area, right? So area is highlighted in this arrow over here, right? So this is our T, right? So T dx. Okay, so dx is a small increment. So if this is a small increment, this is our dz, sorry. Samuel, that's how we do it. Okay, Samuel, you're okay with that? Okay, I think Samuel is okay. Samuel did not reply. Okay, so from here, 2 times 5 over 56 times 2 is equal to minus 5VA over 14 plus by 2 times 15 over 28 is equal to 15 VA over 14. Let me do it again. 2 times 2 times 5 over 56. 5. 2 times 15 over 28. 50. So plus by VE. So finally, VE is equal to minus 5 over 14 plus by 15 over 14 is equal to 5 over 7. So minus 5 over 7, right? VA. Let me do it. Minus 5 over 14 plus by 15 over 14. Yep, minus. So E, our shear center, is equal to minus 5 over 7V. Samuel, I'm reading your chat now. You write YH. Can you speak up? What do you mean by YH? Did I write something wrong? Samuel?
YH just means I'm good. That's all.
What does YH mean, you cheeky sort? Oh, that means that I'm good. Okay, YH. Okay, I'm learning something new. So what you see is minus sign. Minus sign means the shear center is going towards the left. That's why it's minus. So the negative means E is on the left-hand side of point C. Okay, so that's it. Okay, so that is the location of the center. So as I say, it's not difficult at all. I think the worst of you have done already is the thin wall. Okay, thin wall analysis is the worst. Now once you look at all this, so easy. Yes.
I just wanted to ask a question. So for the last two lines, it's the B's that cancel out, right? So it should be negative 5 over 7A?
Yeah.
Yes? Okay, thank you.
Yeah, you wipe this out. So it's negative. Jihan, it is negative. Okay, we did include negative.
Eugene,
And
I think you accidentally put a V instead of an A.
hey?
In the
In
last
the final line.
Ah, okay. Okay, so you all get 2 pints of beer. Okay. Today I think I'm still sleeping, man. Unbelievable. Okay, so we're going to do another example. Okay, we're going to do another example in example number 2. Now we are going to find specific values. Okay, so we are going to where is my you're going to do this question now.
Oh wait, sorry, Eugene.
Yes.
On the diagram, didn't we say that Z going to the left is positive, or did I just not copy that down properly?
No, Z, if you look at the proper transformation, going towards the right is always positive, right?
Okay.
Yeah, so this is going towards the left, is negative because it's going to the left.
Okay, all right.
Okay, you're not wrong. Okay, this is Y and this is Z. Okay, that is the orientation, but we did not use this negative, we did not use Z for this direction. Okay, so in general, anything going towards the left is negative. Anything going to the right is what? Positive. Does that make sense, Marco?
Yeah, I think so. Yeah. Thank you.
So we are going to look at example number 2. Okay, so example number 2 is I'm not saying it's a better example, it's similar, but it has very specific requirement. And I want you to pay attention regarding the geometry. Okay, student always mess up with the geometry. Okay, here we go again. So the extended beam has a cross section shown. Determine the location of the shear center, the distribution of the shear stress caused by the vertical shear V shown at point O. Okay, so now we have to calculate the actual magnitude now. Okay, now we have to calculate the actual magnitude. So like before, observe the geometry, then you construct your shear force. Okay, we're going to construct our shear force. So you construct your shear force. So you have shear force coming down here, going here, or coming down here, going down here, going here, and going here. So this is how your shear force look like. Okay. So we are going to find our shear center first, and I'm going to give this names. Okay. So this is our F1. This is our F2, F3, F4, and this is our V is going down to the center is V. Okay. So we realize that for this case, we are going to find a shear center, right? So we're going to locate the shear center. And like before, when we get the shear center, we're going to take moment at point C to determine the shear center. And to determine the shear center. And this is our point C. And by viewing this, we realize that F1 and F3, right, will generate a moment about point C, right? Will generate a moment about point C. So we do not need to find regarding the shear center, we don't need to find V2, we don't need to find B4, and we don't need to find V for now. Okay, we don't need to locate them for now. Okay, so from here, we just need to find F1 and F3. Okay, so we are going to do our second moment of area again. Yeah, I will copy this diagram. Or I can do the second moment of area over here. Okay, so IZZ is equal to twice IBD. Okay, because IBD and IEF are the same, right? And then I'm going to plus by IAG. Okay, so this will be equal to twice. The width is 4 The depth, do we know the depth? What is the thickness? I forget to read the question. I have not a clue what is the thickness. Do we have thickness? Yeah, thickness is 1 over 8. Okay, so the thickness is 1 over 8. Cube divided by 12. Okay. So plus by 4 multiplied by 1 over 8. And the distance is 3 squared. Okay. Then plus by the width is 1 over 8. The depth is 2 plus 6 plus 2, 10 cube over 12. Okay, so let me see again. Width, depth is 1 over 8. The thickness depends on orientation, so sometimes we are with your depth. And then the area, centroid 3 squared. Okay, then plus by 1 over 8. The width, the depth is 10 cube over 12. So this will be equal to 1 over 8 power of 3. Okay, times 4 divided by. Now, I forgot to tell you. No, I forgot. I just forgot. This term over here is very small. Okay, this term over here. This term over here. I'm going to highlight. I just realized this. This is approximately equal to 0. When I calculate the value, it is equal to 6.51. 04 times, wait, let me do in engineering term. It's 651.04 times 10 to the power minus 6. So it's very small. Okay.